Hi, this is the video for section 7.3. We're going to do more factoring. This time they get a little more complicated because there could be a number in front of the x squared. In the last section, we only did the ones that had a 1 in front of the x squared. Well, an implied 1 because we didn't actually write the 1 there, but this time they can have any number there. So the book refers to this as the AC method. It's a little bit different. When I teach it, it'll be a little bit different because I'm going to use the box to show it. But anything we can do with the box, you could do with grouping, which is the way the book teaches it. The book also teaches a trial and error method, which I think is not a good idea to use, and I won't be teaching that. If you really want to do it that way, I guess you can go to the book. So remember that factoring is unmultiplying. We've talked about that before, right? That when we factor, we kind of figure out, well, what did we multiply together to get this? And so let's just start with, Let's start with a little multiplication problem. We're going to do a plus b. And we do it in the box so we can look at a couple of things. And c plus d. Okay. So, when we multiply, this would be AC, this would be BC, this would be AD, and this would be BD. So now, what we want to look at is the diagonals of the box, okay? So, if you notice, when we multiply on this diagonal, now you can't read what I wrote there very well, but it will be A times C times B times D, and if we rearrange it, it's going to be A times B times C times D. Oh, come on. Okay, and then if we look at the other diagonal, it's right here, right? And we multiply those together, you notice we also have an A, a D, a B, and a C, right? So it's all of those as well. So this one is going, come on, A, B, C, D. So what I want you to notice is that they are the same. Not only are they the same, well, if we simplify them, they are exactly the same. Okay? Now, let's do it with numbers, because that's more likely what we're going to do, right? So here are two factors being multiplied together, and we're going to multiply 2x. Why am I having such a hard time today? And 5x plus 7. All right, so when we multiply, we end up with 10x squared. We end up with 15x. We got 14x. And we have 21. So now, let's look at the diagonals again. All right, so this diagonal here is going to be 210x squared, right? And this diagonal here, if you want to plug that into your calculator, you can. 14 times 15 also turns out to be 210, and we have two x's, so that is an x squared, right? Boy, I'm sorry, I'm making a mess of this time. Okay, now, why does that matter? Well, the fact is that if you have a polynomial that you're going to put into this square and factor it, then it has to be such that the diagonals equal each other when you multiply them. Okay, so if they don't equal each other, so when we did all those grouping problems, right, and we put those four things in there, if they didn't equal each other, then it wouldn't factor. That was when we found that you couldn't factor it. And so what we're trying to do in this section is we're trying to look at how we can break this equation up so that the diagonals will multiply to be the same thing. So let's think for a minute about what it's going to mean, right? So when we have this trinomial, the first one and the last one, they go in that diagonal, right? Now the x squared is not going to matter because the other terms are going to have an x in it. And so we really can just focus on the 3 and the 10, right? So the 3 and the 10 here, that's going to equal 30. So I want to rewrite 17 so that I can break it up into two parts, right? Because when we do this grouping, we have 4 terms, not 3. So I want to break up the middle term into 2 parts so that when I multiply them together, I get the same thing. So that's why I need 2 numbers that multiply to be 30. But when I add them up, they're going to be 17. That's the key here, right? So I can start, and usually there are less possibilities if we look at the factors first. We don't have as many to check, right? So here are the factors of 30. These are all of them, right? So it's either 1 and 30, or it's 2 and 15, or it's 3 and 10, or it's 5 and 6. So 1 and 30 adds up to 31, right? So can you see how we're going to double check these? But 2 and 15, they add up to 17. Okay, so that's the key, that we want to use the 2 and the 15. So that means that I'm going to put 2x and 15x here. And I haven't changed my problem. I've just rewritten 17 as 2x plus 15x, right? That's equal to 17x. So I split it up in a way that my diagonals will equal each other when I multiply, because this one is going to be 30x squared, right? And this one, 15 times 2, that's going to be 30. Okay, so now I can just factor. I factor just like we did all those grouping problems, right? So I pull everything in common out across the top, and that'll just be an x. And that will leave me with a 3x up here. And x times 2 is going to give me that 2x. And 3x times 5 is going to give me the 15. And just to be double check, we'll do 5 times 2, and that's 10. Okay, so those are my answers. Those are my answers. It's the 3x plus 2 and the x plus 5. And I get them from right here. There's my 3x plus 2 and my x plus 5. Now, I don't always put the plus signs, but for sure, if you have a negative, you got to put the negative in there, right? So that's what we're doing. So to sum it up, we're going to multiply the 3 times the 10, and we get that number. And And that is our goal, right? That 30. So then we look for two numbers that multiply to be 30, but they add up to be the middle number, the 17. So that's what we're going to do. So let's try it again. Here's the next one. All right, so first we're going to multiply the 4 and the 35. Kind of a big number. Turns out to be 140. And so if we just start looking for all the factors. Now, I always start with 1. So we look for 1 and the number, and then I just go up the numbers, figuring out which ones go into it, right? So 2 and 70 go into it, but there are a lot for 140. There are a lot. And so I'm thinking that I don't want to do all of them. So I think I'll just skip down a few. All right, so 70 plus 2, 72, that's too big. I'm looking for 33, right? I'm looking for something that's 33. So I'm just going to skip down. I know that 7 goes into 140 because 7 would go into 14, right? So 7 and 20, that's 27. Oh, well, that's too small. I'm looking for 33, right? So I know it's somewhere in between. So I don't have that many to try, right? 3 doesn't go into 140. 4 would go into 140, but 5 would go into 140, and 6 doesn't, right? So I would just try looking at those numbers in between there. That's where I'm going to find it. And sure enough, 5 and 28, they add up to 33. And 5 times 28 is 140, right? So that's kind of how you're looking for them. You find them. So now we go ahead and we factor, right? So the 4x squared goes here. The 35 goes here. And then I had 5. And this totally doesn't matter whether I write 5 up above or 28 up above. It won't matter. You'll just get them in a different order, which is perfectly fine, right? So then we will come across the top, pulling out greatest common factors across the top, and that is just an x. They have nothing else in common. And then I start filling in the thing I have to multiply to get that answer. So this is going to have to be 4x. This will be 5. So 4x times 7 would give me 28. And sure enough, 5 times 7 is 35. So I've got it. And there's our answer. So if you really hate the box, the regular way, and this is the way the book teaches it, is very much the same. You still have to multiply the first and the last numbers to get that key number, and you still have to look for the two numbers that multiply to be that number but add up to be the middle term. And then you just rewrite it. So if you notice here, I've just rewritten the 33 as the 5x plus 28x. Now, we did that in the box, but we just did it in the box to factor, right? And then you're going to factor by grouping, which is you're going to factor the greatest common factor out of the first two and the greatest common factor out of the second two. And then you'll factor out that binomial of 4x plus 5. And then you have it. And you see that we got the same answer. So if you prefer this method, I'm not going to care. I don't care. And maybe it's easier for you to do it on a piece of paper because it's on the row or whatever. You don't have to draw a box. Some people really hate drawing the box, but you can do it however you want, but it still comes down to that grouping method. All right, so let's just practice a few. So remember that we multiply the first and the last. We get 15. We're looking for two numbers that multiply to be 15, but add up to be, it's negative 15. because I have a 3 and a negative 5. So I need two numbers that multiply to be negative 15, but add up to be negative 2. Now, if it's negative 15, that means one has to be positive and one has to be negative. So if we do 1 and 15, well, it could be negative 1, positive 15, or positive 1, negative 15. But in either case, that's going to be 14 or negative 14. That's not what we want. So 2 doesn't go into 15. 3 times 5, right? So this looks like it's going to be the 1. 3 and 5 are 2 apart. And I need it to add up to negative 2. So the bigger one, the 5, has to be the negative 1. All right, so I have my 3x squared, and then I will have to have 3x and negative 5x, and then the negative 5 here. All right, so can you see how we found those numbers? And then we just put them into the box and factor. So this is going to be a 3x, this is going to be an x, this will be negative 5, and this will be a 1. All right, and sure enough, negative 5 times 1 is negative 5. That's just our double check. All right, so that solution is 3x minus 5 and x plus 1. And of course, it wouldn't matter if you wrote that in the other direction, if you did x plus 1 first and then 3x minus 5. Totally wouldn't matter. Okay, so this one is a little bit different. And remember that I told you when we did the greatest common factor that we were going to use it? And so far we've just been ignoring it because we were learning a new method. But always we want to look first for the greatest common factor. Okay, so before you start factoring, before you multiply the 12 and the 12, before you have to look first and see, is there a greatest common factor? Well, can you see something here? For sure we got an x. For sure there is an x as the greatest common factor. And now we look at the numbers. Okay, so 12, well 12 and 12, they have a lot in common, right? They have everything in common. But the 26 is 2 times 13. And so the 2 is going to be in common. The 13 is not going to be in common. 13 doesn't go into 12, right? So it is a 2. So there is a 2x that is the common factor. So we pull that out and we factor that. So we have 6x squared minus 13x plus 6. So now this is partly factored, and we don't want to forget our 2x. But this part, we have to keep factoring, okay? So that's the part that's going to go into our box to get factored. So we're going to multiply the first and the last, and that will give us a positive 36. I'm going to write it down here. And we're going to look for factors of 36 that add up to be negative 13. So since it's a negative, we want both of these to be negative because this 36 is positive. So they have to have the same sign. So we want factors of 36 that add up to be 13, right? So we got 1 and 36. That's 37, so that doesn't add up. We got 2 and 18. Still too high because we're looking for 13, right? But not that much too high, so we don't want to skip too many. So 3 and 12, that still adds up to 15, so that's still a little bit too high. 4 and 9, and there we have it. That adds up to 13. And remember, it's going to be negative 4 and negative 9 because it has to add up to negative 13. Okay, so we put that in here. We have 4x and negative 9x and 6. So we pull out the things that are in common on the top. So it's going to be a 2 and an x. And this will be a 3 and an x. And this will be a negative 3 to make that a negative 9. And this will be a negative 2 to make that a negative 4. And sure enough, we double check. Negative 3 times negative 2 is positive 6. Okay, so these are my 2 answers for this part. But don't forget this. That has to also be part of our answer. Okay, so we have 3 parts. We have our, we have our 2x, we have our 2x minus 3, and we have our 3x minus 2. See? Okay. Okay, let's try another one. So this time, I want you just to pause it and see if you can look for the greatest common factor and factor that out. Okay. Hopefully you found that there is a greatest common factor of 2. So this becomes, this becomes 2, and then we have to factor it out. So we have x squared plus 6x plus 5. And actually, I made a box here for us, but we don't really even need the box because this is just like the ones we did last time. We're looking for something that multiplies to be 5, but adds up to be 6. So that's going to be 1 and 5. So this is the one that we just put straight into it because it has the x squared first, right? So x plus 1, x plus 5, and don't forget the 2. All right, so, and then I left off the 2 out of the answer. So that should have a 2 there. Okay, here's another one. Pause the video so you can try this out. Check for a greatest common factor, and then see if you can factor it. All right, hopefully you found that there is no greatest common factor. There's nothing that goes into 6 that also goes into 5. So this one, we are going to multiply the 6 times 5, and we get 30. We're looking for 2 numbers that multiply to be 30, but they add up to be negative 31. So a 1 and 30 is what's going to add up to that, and they have to both be negative. And so it really doesn't matter which one goes where. You should even try it sometime and see, try it both ways and see which way, see if you get anything different. You might get them in a different order. Different factors will be on top or side, but they are both still the same factors. All right, so when we pull the common factor out of the top, it's going to be an x. So this will be a 6x, and this will be a negative 1. And 6x times something, it will be negative 30x, right? So we need a negative, and we need a 5, because 6 times 5 is 30. And sure enough, negative 5 times negative 1 is positive 5. So those are my answers. 6x minus 1 and x minus 5. Okay, I think this is the last one before we move on and do some practicing. But this one is important to think about because in all the ways that we have been doing it and the ways that we have been setting up our factoring and the 2 numbers multiplied together and the way we do it, we've always done a positive number as the first number. So you may not have noticed that, but it was deliberate. We always do a positive number as the first number. So if there's a negative there, like in this case, then we need to factor out that. So there isn't any other common factor, but just a negative 1. And you can think about it as being factored out of a negative 1. So now it's going to be positive 2x squared. And then all these signs are going to change. And remember that if you went back and distributed that negative 1 in, you should get back to what you started with. Okay, so this is going to be our 2x squared and negative 6. Now we're going to multiply the 2 and the negative 6. We got negative 12. We need two numbers that multiply to be negative 12, but add up to be positive 1. So we've got 1 and 12, we've got 2 and 6, and 3 and 4. And 3 and 4 are only 1 apart. So those are the ones that are going to work. And I want them to, one's got to be positive, one's got to be negative, and I want them to add up to a positive, because we're dealing with the factored one, right? So we need a positive 4 and a negative 3. So one will be negative 3x, one will be 4x, and then we factor. So pull the common thing out of the top. That's going to be an x. So this has to be 2x, and this has to be a 2, and this has to be a negative 3. And 2 times negative 3 is negative 6. So it worked. And there are answers. And you can leave that negative 1 out in front. You can put it as just a negative if you want. But typically we would just leave it out, not factor it back in. Okay, so just a couple of things to note. If it says factor completely, then you really need to take every factor you get, every answer you get has to be completely factored. So if you notice, in a problem like this works. And if you multiplied this out, we'd get 2x squared, and we'd get 2x and 10x, that'd be 12x, and we'd get 10, and that's great. But 2x plus 10 has a common factor. It's equal to 2 times x plus 5. So this is not completely factored, right? In order to be completely factored, you have to go all the way to this, right? Now, this problem can be solved by doing that very first step of factoring out the greatest common factor. So at the very beginning, if you had factored out a 2, then it would be already factored out, and you wouldn't have to have factored it out again at the end, right? So it's just a good idea to always factor it out, and then you will have it done, and that will be your factor, and you're working with smaller numbers too. All right, so here are some practice problems. Practice factoring these. Come back and I'll show you the answers. If you want to see any of these and how they were worked out, we could do that in class on Zoom. And but make sure you don't forget to look for a greatest common factor in every case. Okay, here are the answers. Once again, the order of the factors doesn't matter. You can have them switched and it will still be correct. I'll see you later.